Fighting plastic pollution. Why reducing is better than recycling. Recycling is commendable, but reducing waste is even more crucial. Tackling plastic pollution at its source. Every year, the global production of plastic reaches staggering new heights. In 2021, the OECD reported that over 400 million tons of plastic were generated worldwide, which is double the amount produced in the early 2000s. If current trends continue, we could see plastic consumption increase threefold by 2060. However, the recycling efforts are lagging significantly behind this rapid growth. According to OECD statistics, only about 9% of plastic waste is recycled, while 19% is incinerated, and nearly 75% ends up in landfills or is discarded into the environment. The hidden dangers of ubiquitous waste. Plastics can take anywhere from 20 to 500 years to decompose, and even then, they do not completely vanish. Instead, they break down into microplastics, tiny particles measuring less than 5 millimeters. These remnants from everyday plastic items are infiltrating our oceans, soils, rivers, and even living organisms, including fish and humans. Research has confirmed their presence in drinking water, breast milk, and even human blood, raising alarming concerns about potential health risks. Europe's response to the waste crisis. In light of this pressing issue, the European Union has implemented a series of initiatives in recent years. Since 2021, a ban on single-use plastics has been enforced, targeting widely used and easily replaceable items like bags, straws, and cutlery. New regulations on packaging are designed to minimize excessive packaging and enhance the recyclability of materials. The intentional inclusion of microplastics in certain cosmetics, detergents, and industrial products is restricted under the European REACH regulation. A proposed regulation concerning maritime transport aims to reduce the loss of industrial pellets, which contribute to microplastic pollution. The Marine Strategy Framework Directive, which seeks to safeguard marine ecosystems from litter, is currently undergoing revisions. Additionally, the EU is funding various research projects focused on creating biosourced and biodegradable alternatives to conventional plastics. Notable examples include the Sea Life project, led by the ETENE Research Center in Valencia, and the R3PAC initiative. Brussels is also working towards optimizing the economic viability of reuse systems, with a goal of achieving 100% reusable or recyclable packaging in the market by 2030. Towards a global treaty on plastics. On an international scale, the EU is advocating for a legally binding global agreement to combat plastic pollution. Negotiations for this draft treaty have been ongoing since 2025, revealing two distinct perspectives. A high-ambition coalition, which includes over 100 members such as the EU, Rwanda, Norway, and Peru, is pushing for a legally binding agreement that encompasses the entire life cycle of plastics, addressing both upstream and downstream measures. Conversely, some countries, particularly major oil producers, prefer the agreement to concentrate on downstream strategies like waste management and recycling. The upstream measures, which are currently a topic of intense debate, include promoting sustainable production and consumption of plastics, tackling issues related to problematic plastic items such as single-use plastics, reducing the use of hazardous chemicals. The next round of negotiations is scheduled to take place in Geneva from August 5th to 14th, 2025. The hidden truth about plastic recycling. Science, challenges, and future fixes. This is the plastic crisis we can no longer ignore. Our reliance on recycling as the silver bullet for plastic pollution has hit a wall. Not just because of how people dispose of bottles and bags, but due to hard scientific limits in chemistry, physics, and engineering. Since the 19th century, we've been playing a high-stakes game of environmental roulette. Back in 1862, Alexander Parkes introduced Parkesine, the world's first man-made plastic, made by treating cellulose with nitric acid and a solvent. Seemingly harmless at the time, that invention ignited a revolution in material science and set us on a path to today's plastic-drenched world. celluloid, bakelite, PVC, nylon, PET, the list goes on. Those early breakthroughs promised convenience and durability, but they also planted the seeds of a pollution nightmare that is only getting worse. They stumbled across countless microplastic fragments tangled in seaweed, an early warning sign that plastic wasn't just piling up in landfills, it was infiltrating the very heart of Earth's ecosystems. In response, engineers championed recycling as the answer. Collect, sort, clean, melt or break apart, then remake. It sounded perfect. Reduce waste, save resources, and keep plastic out of oceans. But decades into this approach, we've discovered some harsh realities. But here's where it gets controversial. Recycling may seem like a straightforward solution, yet every method, mechanical, chemical, or energy recovery, is shackled by the same physics and chemistry that give plastics their strength. 1. Mechanical recycling is today's go-to for PET. Think soda bottles and HDPE, milk jugs. It involves collecting, sorting by type and color, washing away labels and residue, drying, grinding into flakes, then melting and repelletizing. It's proven at scale, but contamination is a constant headache. A single drop of PVC in a batch of PET can generate benzene, a known carcinogen. Plus, repeated melting degrades polymer chains, so quality diminishes over time. 2. Chemical recycling is the newcomer on the block. By cracking plastic molecules back into their base building blocks, it promises to handle tough items like snack wrappers and multi-layer films that mechanical systems can't process. Techniques include pyrolysis, heating without oxygen to produce oil-like fuel, gasification, partial oxidation to make syngas, hydrocracking, using hydrogen to split long chains, and depolymerization, breaking polymers into monomers ready for new plastic. It's exciting but expensive. Think USD 300 to 1,000 per ton, and currently limited to pilot plants. 3. Energy recovery simply burns the plastic for heat or electricity. It taps into the high energy content of polymers, but doesn't return any material for future use. Plus, emissions from combustion may include toxic byproducts like dioxins and sulfur dioxide. And this is the part most people miss. Recycling doesn't come cheap. Operating costs for mechanical recycling range from USD 50 to 200 per ton. If we tried to recycle all 460 million metric tons of plastic produced each year, it could cost us up to USD $92 billion if it were even technically feasible. Energy use makes up about a third of that cost, yet recycling 1 ton of plastic still saves roughly 5,774 kilowatt-hours of electricity, 16.3 barrels of oil, and about 30 cubic yards of landfill space, compared to making virgin plastic. Overall, recycling slashes energy consumption by more than 80% versus new production. But what lurks inside those recycled polymers might shock you. Recycling doesn't eliminate harmful additives or pollutants. It often locks them into the new material. A 2023 Greenpeace report exposed elevated levels of flame retardants, carcinogens, hormone disruptors, and persistent pollutants like brominated dioxins in recycled resins. Mechanical recycling can even produce fresh toxins when overheated, and chemical methods such as pyrolysis risk releasing mercury, arsenic, or formaldehyde into the environment. In fact, a recent study from the University of Gothenburg and Leipzig University detected over 80 distinct chemicals in a single recycled plastic pellet. Everything from UV stabilizers and plasticizers to unexpected contaminants like pesticides and pharmaceutical residues. Eric Carmona of Germany's Helmholtz Center points out that these surprises highlight how little we know about the material cycles we've created. This detail is controversial. Should we keep dumping energy and money into imperfect recycling, or accept that some plastics may be destined for one-time use? And if so, what alternatives truly measure up? Innovations are bubbling up. From mushroom-based packaging that breaks down harmlessly in soil, to next-gen biopolymers designed for easy composting. Entrepreneurs and researchers are reimagining what comes after plastic. Meanwhile, paper and cardboard remain our best biodegradable stand-ins for packaging. Yet experts like MIT's Elsa Olivetti stress that real progress means rethinking the entire life cycle, from design to disposal. Clear regulations and supply chain standards are critical. We must trace every chemical from factory floor to landfill to ensure safety. Bethany Carney-Almroth of the University of Gothenburg warns that without robust chemical tracking, even the most sophisticated recycling systems will be stuck recycling problems, not solutions. Until then, the same chemistry that gave plastics unmatched resilience will continue to limit our ability to reuse them fully. So, what do you think? Should we forge ahead with current recycling technologies, invest more in radical redesign, or simply reduce plastic use across the board? Share your thoughts, agree, disagree, or challenge the consensus in the comments below. The truth about plastic bag recycling. Tracking experiment reveals shocking results. Imagine a world where the very systems designed to protect our planet are actually contributing to its destruction. This is the harsh reality of plastic recycling in the United States, where millions of plastic bags are collected each year, only to end up in landfills, incinerators, or worse, exported to other countries. But here's where it gets controversial. The American Chemistry Council, a trade association representing plastic manufacturers, has been promoting a recycling program that promises to make it easy for consumers to recycle their plastic bags. However, a recent investigation by ABC News has uncovered the dark truth behind this program, and it's not pretty. The investigation, which involved placing dozens of trackers in plastic bags meant to be recycled, revealed that the vast majority of these bags do not end up being recycled at all. In fact, many of them were found thousands of miles away from the US, in countries like Indonesia and Malaysia. So, what's going on here? The problem lies in the fact that the plastic recycling industry is dominated by the same companies that produce the plastic waste in the first place. These companies have a vested interest in maintaining the status quo, rather than investing in real solutions to the plastic pollution crisis. As Judith Enck, president of Beyond Plastics and former EPA regional administrator, pointed out, no responsible waste company in the United States, no responsible local government should be exporting plastic waste to other countries. And this is the part most people miss. The plastic recycling industry is not just a matter of personal responsibility, but also of corporate accountability. The fact that companies like Walmart and Target refuse to be interviewed or allow investigators to track the fate of their plastic drop-off bags speaks volumes about their commitment to transparency. By raising awareness about the reality of plastic recycling, we can push for real change. As Courtney Williams, a resident of Peekskill, New York, suggested, consumers need to be made aware of the consequences of plastic recycling and how it affects the air they breathe. So, what can you do? Start by reducing your use of single-use plastics and support organizations that are working to create a more circular economy. And when you do recycle, make sure you're doing it responsibly. The future of our planet depends on it. But here's the question. Are you willing to take a stand against the plastic pollution crisis, or will you continue to contribute to the problem? Let us know in the comments. The truth is, plastic pollution is one of the greatest factors in the degradation of the planet's natural resources. And it's up to us to demand better from our governments and corporations. So, let's get the conversation started. What do you think is the most effective way to tackle the plastic pollution crisis? Should we focus on reducing plastic production, increasing recycling rates, or something else entirely? Share your thoughts, and let's work together to create a more sustainable future.